All right, so we're going to continue getting some practice with noticing perfect square trinomials and factoring them. These are examples that are slightly more complex. Okay, so in this first example, we have x squared y squared plus 12xy plus 36. Okay, so a major difference here, of course, is we have two different variables here, but when we think about the perfect square trinomial, x squared y squared is a perfect square, and I notice that 36 is a perfect square, right? 6 times 6 is 36. And in the middle there, I think about x, y, and 6 being our a and b respectively. 6xy times 2 is 12xy, okay? All right, so I can think it through that way. And when I go to factor this, I'll have xy plus 6 quantity squared. Now, why plus 6? Well, the middle term is positive, right? So if the middle term was negative, then we would have a minus 6, okay? So again, this only works when the first term and the last term are perfect squares, and when you take the square root of both of those, the first term and the last term, and multiply it by 2, you should get the middle term. So that middle term is important too. But generally speaking, if that's all in place, this is a really slick method. All right, so just to check this, and especially when we're factoring a special form, if we didn't do the arithmetic right to get that middle term, you just want to make sure. Did we do this? Okay, so xy times xy is x squared y squared. Xy times 6 is plus 6xy. 6 times xy is plus 6xy. And 6 times 6 is 36. Okay, so I'm going to clean up the middle term. X squared, y squared, 6xy, and 6xy is 12xy. And got the 36 off on the end. Okay, so we get the x squared, y squared plus 12xy plus 36, right? It's all the same thing that we started with. So with 81r squared minus 54rt plus 9t squared, I notice that 81 is a perfect square, right? 9 times 9 is 81. And 9 is also a perfect square, 3 times 3. Okay, and so if we take those square roots, right, the 9 and the 3, and multiply them, we get 27, right? And one has an r and one has a t, right? So 27 RT. If we multiply 27 by 2, do we get 54? Yes, we do. Okay, so this technically should work. Now, before we go ahead and do that, and we could totally do it and then take a look at what we've got from there, but I notice that 54 is also divisible by 9, right? So 81, 54, and 9 all divisible by 9. So let's pull a 9 out. So if we do that, we're going to have 9r squared. 9 times 6 is 54, right? So minus 6rt plus t squared. Okay, so if you notice things like that, it can make things easier. Is this still a perfect square trinomial? It is, right? 9 and 1 are both perfect squares, right? R squared and t squared are perfect squares. And since we know that the original one factored, we already sort of talked that through, this one should factor as well. So square root of 9r squared is 3r, right? And the square root of t squared is just t. And the middle term is negative here, so we're going to have 3r minus t. Right, quantity squared. So let's check this. So we've got 9 times 3r minus t times 3r minus t, right? I'm going to expand it here just to make sure we did this right. So leave the 9 alone. I'm going to FOIL this out, right? 3r times 3r is 9r squared. 3r times negative t is minus 3rt. Negative t times 3r is minus 3rt. And negative t times negative t is positive t squared. Okay. So we have 9 times 9r squared, negative 3rt minus 3rt minus 6rt, yeah, plus t squared. Okay, and then we're going to distribute the 9 through. So 9 times 9 is 81, r squared. 9 times 6, negative 6, negative 54 RT, and 9 times t squared is plus 9t squared. Okay, so it does work, right? We got back to the original statement that we started with. Now, before I leave this, I want to go with a little aside here. Because initially when we said, okay, well, 81 and 9 in our original statement, those are perfect squares. And we kind of talked through the fact that we would get 54 in the middle if we factored it out that way. So let's see, this is going to be a big or, right? This is another way to do it. So the square root of 81r squared is 9r, right? And the square root of 9t squared is 3t. And we've got a negative in the middle, so we have 9r minus 3t, right? Square root of 9t squared is 3t, right? And we're going to have that binomial squared, right, when we factor. Okay, so is this the same thing as what we ended up with? Well, I'm going to come down here. If you think about 9r minus 3t times 9r minus 3t, you can factor a 3 out of both of those, right? So I'm going to factor a 3 out of the first one. I'll be left with 3r minus t. And I'm going to factor a 3 out of the second one, and I'll be left with 3r minus t. Yeah? And so 3 times 3 is 9, right? And then I've got 3r minus t quantity squared, right? So it's the same thing. So it's usually always better to factor the GCF out first. It usually makes the arithmetic a little bit easier and the numbers a little easier to work with. And so we always encourage you to factor it out. But if you miss it and you factor it out later, you'll end up with this in the same place, okay? So I just wanted to make that note. Okay, so let's do this last one. Woof. 121 p to the 12th minus 88 p to the 11th plus 16 p to the 10th. Okay, I know that 121 is 11 squared, and I know that 16 is 4 squared. Okay, I can pull p to the 10th out of that, so minimally I want to do that. And I'm wondering if there's anything amongst the numbers that I could pull out that I'm seeing. 121 isn't even like the other two are, so let's. Sometimes if you don't see it, again, you can factor it out later if it becomes obvious. But for the moment, let's get the p to the 10th out. That's a GCF we can pull out. So we have 121 p squared minus 88 p plus 16. Okay, let's just think this through for a minute. The square root of 121 is 11. The square root of 16 is 4. 11 times 4 is 44. And 44 times 2 is 88. Okay, so perfect square trinomial. Great candidate for it. So we've got p to the 10th, and then the binomial squared that we're looking for is 11p, right? Square root of 121p squared is 11p. The middle term is negative, so I'm going to have 11p minus 4 quantity squared. Okay, and now we're just going to check that. So we're going to say p to the 10th times 11p minus 4 times 11p minus 4. So this is what we're trying to expand. All right, so I'm going to leave p to the 10th alone, and I'm going to FOIL. 11p times 11p is 121p squared, right? 11p times negative 4 is negative 44p. Negative 4 times 11p is minus 44p. And negative 4 times negative 4 is positive 16. So I've got p to the 10th times 121 p squared, negative 44 minus 44, negative 88, right? So we're going to have minus 88p in the middle there, plus 16, okay? And now all that's left to do is to distribute the p to the 10th through. So p to the 10th times p squared, so we've got 121 P to the 10th times p squared is p to the 12th minus 88. Let's see, p to the 10th times p is p to the 11th plus 16 p to the 10th. Okay, is that what we started with? Yes, it's the original expression. Okay, perfect. So these are some great examples to talk through in terms of noticing perfect square trinomials. And one of the biggest pieces of advice that I can give you if you have a hard time recognizing this, make sure that you get back with the times table and just know what the perfect squares are. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, right? 5 squared is 25, all the way up through 12. Just know what they are, be able to recognize them really quickly, and that will really help a lot with this factoring process with perfect square trinomials. Okay, wonderful.